Greetings, everyone. Thank you for joining us at Exchanging Ideas 56. I'm Kanishwaran Govindasamy, the founder of Global 5G Evolution. To the speakers all around the world, I thank you and I'm so grateful to have you in this event. I really appreciate that. To the audience, please take a couple of seconds to click the subscribe button on our YouTube channel. Today's presentation will topic is elevating 5G with differentiated connectivity by Ericsson's Consumers Lab research report most recently. As a consumer-focused survey, Ericsson wanted to see how consumers used digital services, their thoughts on 5G, and what could elevate the experience of the network. Ericsson found that 5G users reports higher performance satisfaction than 4G users, but face issues in high traffic locations, meaning that 4 in 10 users are no longer willing to accept best effort 5G performance. And 35% of the surveyed 5G users show a growing appetite for elevated connectivity beyond standard 5G performance, signaling a strong willingness to adapt and pay extra for differentiated connectivity. Now, the research highlighted that frequent network connectivity issues in crowded places such as event venues and airports have a significant negative impact on consumer loyalty. Frequent issues with a quality of app experiences at crowded locations have led 4 in 10 5G users to set higher expectation on network performance, with many now saying they are no longer willing to settle for standard best effort 5G. And this shift underscores a clear opportunity to differentiated connectivity, and it is essential to resolve 5G coverage issues, especially indoor coverage, proactively, which will enable a more reliable and high-performing network in the future. Now, densely populated countries such as India, Thailand, and Brazil have 1.5 times more users interested in paying for differentiated connectivity in comparison to the global average. These are mobile-first markets where reliance on mobile connectivity is particularly strong. In these markets, elevated demand for differentiated connectivity could be attributed to the need of improved capacity. From here, we can see that 5G users are interested and willing to pay a moderate premium for differentiated connectivity for core services such as video calls for work and personal reasons and streaming various media formats. However, the highest premium is set for niche services such as multiplayer mobile gaming, cloud gaming, differentiated augmented reality apps, and payment and banking services as well. Ericsson anticipate a substantial increase in generative AI usage over the next 5 years, with the expected 65% of weekly users engaging with these applications. Now, this is quite an interesting slide where Ericsson identified 5-stage roadmap aligned with the 5G network evolution. Stage 1, service providers rely on selling large volumes of non-differentiated best effort connectivity, typical flat rates, and unlimited mobile broadband plans. Stage 2, it's evolved monetization with general performance assurance features such as speed tiers or broadband traffic prioritization during congestion periods. Stage 3, targeted performance enhancements within specific geographic zones where 5G standalone is deployed, offering elevated connectivity at concerts and airports, etc. Stage 4, deploy 5G standalone networks at a broader city um, or a multiple city scale to offer differentiated QoS packages tailored to specific segments, for example, like professional gamers. And stage 5, innovate with a B2B2C platform centric approach by exposing network APIs and by establishing a QoS focused application marketplace. And Ericsson found that around two-thirds of 5G users reported having a leftover data allowance more than 30 GB by the end of the month. Now, capture the full revenue potential of differentiated connectivity. Ericsson research reveals that service providers cannot capture the entire consumers market with differentiated connectivity through selling direct subscriptions or demand performance add-ons. While 45% of consumers prefer to pay service providers directly for differentiated connectivity offerings, a significant 25% of 5G users prefer alternative payment models. And this group favors in-app purchase, apps with built-in elevated connectivity, or devices like 5G laptops and smart glasses bundled with QoS features. And the remaining consumers remaining uncertain about the value of differentiated connectivity, underscoring the need for service providers to adapt creative, flexible business models to capture the broader market. Ericsson Consumer Lab conducted research at three big events in Europe during the summer in 2024. And these were the Euro 2024 Football Championship in Germany, the Taylor Swift concert in London, UK, and a global sports event in Paris, France. The consumers were asked about the frequency of the event attendance at big events and their reliance on smartphones and mobile applications during such events, and the overall expectations of 5G connectivity. The result was network traffic shift dynamically during big events, driven mainly by two significant mobile app usage behaviors. The event goers using uplink centric apps or numerous event goers connecting simultaneously to the networking using the downlink centric apps. At the beginning of events, it was noted that upload centric apps were using with 53% of consumers stating they were live streaming, while 44% were uploading videos and images. The significant peak in data traffic dropped during the break time. And looking at the traffic peaks towards the end of the event, the downlink centric apps contributed to the sudden and sharp rise in data traffic. And the usage of video watching apps was also reported as consumers wanted to catch up on what other event goers had posted and also to see the outcomes of parallel events that they did not attend. So the issues impacting the experience of mobile users at big events, slow networks speed being the most frequently occurring challenge. Consumers instead identified mobile app quality of experience and network reliability as the main issues that impacted their experiences greatly, being 10 times more important than a slow network. And they view and interact with their apps as tools to enhance or elevate their experience, and not having the QoE in their apps leads to disappointment. QoE, the quality of experience here. And lastly, the option of setting or getting enhanced connectivity via the ticket bundling attracted additional 21% interest from the consumers. This indicates that ticket bundling taps into a new segment of attendees at big events, offering a unique value proposition for service providers that goes beyond the typical interest in an on-demand performance boost. Ericsson noted that 4 in 10 consumers are interested in paying to access performance assurance at big events, and the figure looks more closely at consumer interest in getting enhanced connectivity via the ticket bundling. Event attendees are willing to pay a premium which ranges from 5 to 15% on top of their ticket prices. So this is the overall of the latest Ericsson Consumer Lab research report. Thank you so much from my side. And I would like to introduce our next speaker, Nishma Patel led from Cheriton, England, to present private 5G setup and potential use cases. Over to you.
Thanks, Ganesh. Very interesting. Can you all see my screen now?
Yes.
Okay, perfect. So hi everyone, I'm Nishma Patel Ladd, a program director who has fallen into private 5G. Everything Kinesh was saying actually really resonates, and it's very interesting because that's why we're seeing people want to come over and use private 5G because it gives them better coverage, better connectivity. And just on the events piece that you were talking about there, I've seen concepts called private 5G on wheels to help with that type of thing. So today I'm going to go through what actually is private 5G, why would we use it, the setup and architecture of it, potential use cases, and also running a program. Is it any different to running a normal program or something different? So a private 5G, and I've put it, network is a dedicated, secure 5G network deployed in a specific location for specific needs. It's also usually owned by a specific organization, which differs from public 5G, which tend to be owned by MNOs, kind of like what you've just said before me, Kinesh. Currently, they're actually being used in multiple different industries. So, manufacturing, they're using them for real time monitoring, automation of production lines, making it a bit more efficient. But you could also use it for sense data, monitor performance, predictive maintenance needs, optimize operations. Um, there's also potential use cases for augmented reality, virtual reality, for example. So if you were manufacturing cars, you'd be able to visualize and collaborate on the product design together. Also, again, within healthcare, you've got secure high-speed connectivity for telemedicine, real-time patient monitoring, maybe video conferencing. You could even proactively monitor stats of patients, so with alarms going off if anything goes wrong. Or there's also logistics, where again streamlining supply chain operations. You do demand forecasting. You know what's in terms of inventory. I think the real interesting one for me is smart cities. So I've put real-time traffic management because I think that's a use case I'd love somewhere to implement, especially on a Monday morning when there's traffic everywhere. And for this to me means so being able to monitor traffic conditions in real time and adjust the traffic signals to optimize traffic flow. So if I was sat there a few months ago, I'd be going, well, why can't you just use Wi-Fi, or why can't you just use normal 5G? Well, the key advantage really is low latency. So you get to deliver faster response times, and that's crucial for real-time applications, really. You get high security with it, enhanced encryption, get to access control, customizable coverage. So, like I've already said, specific user, specific location, enhanced reliability, also cost efficiency. So you possibly can lower your operational costs through real-time data. So you've got faster decision making. You can be more proactive with your decision making as well. And it's scalable. There are disadvantages, so there are challenges with anything. A few are there probably is going to be high significant upfront costs. So you'll have infrastructure, you'll have software, you'll also have spectrum licenses depending on where you are. Then you've got your network deployment and your maintenance. Your network deployment usually could be quite complex, but also it's to do with technical expertise that there might not be that many of them. So something that we find is finding that technical expertise in order to deliver our projects. It's kind of hard out there. There's also regulatory requirements that you need to think about. So your spectrum licensing, like I've said before, there could be it could add more time to your programs. There's also compliance that you need to think about, so security, data privacy regulations. the final one, again, something I've seen, limited vendors who are offering this. So in terms of hardware and software, so it kind of means that you might have to pay a premium to have those services, but also you're kind of dependent on those vendors. So testing is key. In terms of a private 5G setup, so you've got your core, which is your central component essentially. You've got your RAN, which is your radio access network, and it's the interaction between these two really that gives you that private setup. But everything always starts with your devices, because your device needs to do something, whether it's to upload data, download data, for example. So I'm going to concentrate on some of the use cases that I've actually seen. So IoT and automation, this is what I've had the most experience in. AVs is one that I'm working on at the moment. So that's autonomous vehicles. And this is real-time communication for navigation purposes. So, for example, in complex warehouse situations, these vehicles could transport goods, making that whole operation process more efficient. If I was taking it one step further and thinking about smart cities, you could even think about autonomous delivery vehicles. Again, maybe improving delivery times for packages going to the home or to the business. Another one, asset tracking, which I touched on previously. So again, use real-time tracking for goods. So for example, container tracking at ports, you know exactly where those containers are and where those goods inside them are as well. In retail, a use case would be, again, inventory management, which I touched on before, linked to an automated reorder based on real-time and predictive data analytics. So quite powerful, really. Remote monitoring, so monitoring your equipment, again, for efficiency optimization, environmental sensors, real-time air, water quality monitoring, another use case. And one which we're looking at currently is agricultural automation. So this is being able to look at farming methods and monitor them, and maybe even automate providing certain nutrients to them. In terms of future trends, I think everyone's talking about AI and actually how we could use private 5G within that space. Now, a couple of use cases that I think could be predictive maintenance, so utilizing the AI to analyze network data to predict potential equipment failures, again, allowing for proactive maintenance, reducing downtime. Self-healing networks. Now, this is, I guess, a very new thing, but one that I was thinking about, where AI-powered systems can automatically detect and resolve network issues, improving network reliability, helping your operations, keeping things more efficient. So I think potential use cases, they're quite powerful, actually, when you think about organizational efficiencies. Now, setting up a private 5G network program, it's not really that difficult from any other program that you would set up. There are a few different aspects involved, but generally it's the same way I would run any program. So initiation, why are you doing it? What's the benefit? Who are your stakeholders? Completely exactly the same as any program would kick off. However, you would also need to make sure you've got the correct spectrum acquisition. So you need to identify what spectrum you need. You need to have a look at what use cases you've got. You need to consider factors like bandwidth, latency, and coverage. That is different from, I guess, other infrastructure other infrastructure programs. But also spectrum licensing. So you need to obtain necessary spectrum licenses from your relevant regulatory authority, which we've had to do. In terms of network and security design, so you'll have your core network, which is a robust core network to provide essential network functions like routing, switching, security. And then you've got your RAN, so you'll have to make sure that you know where your base stations are going, it's got adequate coverage and capacity. You might have to consider other factors like the building, the terrain, how many connected devices you're going to have. And in terms of security, what kind of security measures are you going to implement that protects your network from cyber threats? Moving on to network deployment and integration, well, that's deployment of your base stations, your antennas, your radios, your servers, configuring all of that. Integration with your IoT devices, so your sensors, your cameras, maybe even existing systems that are out there. And because I would say some of that is new, maybe not so new for some people, but it is new for some of the clients that I've been working with. Testing and optimization is key. So you've got to make sure that your network performance tests are thorough, you test for latency, throughput, and reliability. And then if there are any issues, you obviously optimize based on those. In terms of operations monitoring, you're able to continuously monitor the network, identify any issues, resolve them, and then it goes into your maintenance and review cycle.
Nishma, the 10 minutes is already over. Would you mind to quickly wrap?
I've just finished actually.
Oh,
So
fantastic.
let me stop sharing. So I was just going to say, we've been through quite a bit there actually, but to summarize, my key learnings are that by leveraging the capabilities of a private 5G network, organizations can achieve greater efficiency, productivity, and innovation. Thank you.
Fantastic. That was brilliant presentation. Thank you so much, Nishma. Appreciate that. Let me introduce next speaker, Haida Mehdi Haideri from Seoul, South Korea, to present on flying base stations for beyond 5G communications using UAV.
Hello, everyone. Thank you, Nishma, and thank you, Ganesh, for giving me an opportunity to present ahead of you people. Can you people see my screen?
Yes, sir.
So, as mentioned by Mr. Ganesh, today I am here to present the application of UAVs in wireless communication through and inbound 5G communication. Before it, it's the short introduction of myself. I have graduated and master's from Pakistan, and then this year I came here to pursue my PhD. And after graduation, I have spent 10 years in professional industry working as a radio network optimizer on all layers 2G, 3G, 4G, and last mile 5G in Iraq, in all multi-vendor experience, including ZTE, Ericsson, and Huawei. So let's start. What are UAVs? As depicted by the name, unmanned aerial vehicles, normally known as drone in our society. And it's a, you can say aeroplane, but not driven by the human pilot. We can control it through remotely. And below some snaps are the possible applications of UAVs. Some of them are already deployed and some of them will definitely be deployed in future, like UAV assisted as a smart city in hotspots for user perception rate, for the better user experience, for the surveillance used by army, already used by army, and also in disastrous area like fire eruption, like flooding, like earthquake. Our rapid response team used UAVs for the location and evacuation of people in complexities. And also the vast application are used in agricultural aspects for land refarming, for land holding, and many other aspects. So why UAVs in wireless communication? For the seamless coverage, we need UAVs. As in UAVs, we have a line of sight concept. Better the line of sight, better the communication, lesser the noise. And definitely it will improve the user experience. In the existing network, we have a lot of glitches, like we have packet loss, we have higher latency, and we have other ambiguities. But through UAV, we can combat or we can mitigate these deficiencies. Some of the measurable benefits are flexibility, cost efficiency, rapid deployment. Flexibility means we can deploy it as per our need on a large scale, on a maximal point, or on a minimal point. Cost efficiency, as you know, the old-fashioned iron base station cost more than 10 times of a single deployed UAVs. So it's more cost effective as compared to old tradition base station. And rapid deployment, we don't need to build an infrastructure to deploy the team for civil work, then deployment for fiber work, and then on the other side. We just launched the UAVs, the drones for the coverage of our network. Applications in dynamic environments, as I mentioned earlier, we can use it in need of desire, as we need in a disastrous area, we need in remote area, we need in highly populated urban area. It's up to us. Real-time monitoring, security surveillance used by army, and remote sensing for civil work for the benchmarking of any in specific area, we can use it. So UAV as flying base station. We can normally the terrestrial base station, we can call it as a ground base station, and for drones we can call it flying base station. They can be a commercial hubs and beneficial for those users who are highly isolated, for a remote user who are far away from downtown, from the city center, and from the major city, and it's quite impossible for customer these days, for the connectivity provider companies to deploy tower, as they need some business from there for remote user. But UAVs will be an option for them to cater the coverage deficiency, and it will provide seamless connectivity. As mentioned in picture, you can see the drones and the flying users, the ground users, all are equally entertain the services of UAVs. So its application in disaster response and recovery. Let's suppose we have some flood affected areas, and all of our ground infrastructure was wasted in flood, and it take almost week or more than a week to redevelop network, to relaunch our services. But by just deploying a single or more than single UAV, two UAVs or three UAVs, we can somehow merely able to provide connectivity to the people who are stranded in emergency areas. They can call the relief teams to provide seamless relief, and they can talk with their relative ones. But if we rely on the old network which was wasted in the flood and earthquake, then it would be difficult for the team. Then the remote areas, as I mentioned earlier, you can see in the picture, it's bridging the digital division. As in our society, there is a division of remote and urban areas, and in remote areas, we have experienced a lesser count of node Bs as compared to urban areas. So we can provide connectivity through UAVs, through drone stations, through flying base stations, and undeserved regions which are deprived of the connectivity. We can provide the connectivity through this. Also, the previous one was the example of coverage enhancement, but now we can use it as a capacity enhancement. Let's suppose we have some special event in our city. Let's suppose we have Olympic, we have some football match, or we have some traditional event. And for those events, we have some congestion in our network. So UAVs can be deployed to mitigate that congestion for the better user perception rate, for the video voice quality, for the higher codecs, for the higher spectrum utilization rate. These UAVs will definitely cater the deficiency of internet speed, the minimal internet speed, and can enhance the internet speed, because higher the bandwidth, greater will be the throughput, and we can deploy carrier aggregation and band addition through these UAVs. And the next step, we can use UAVs for Internet of Things, for the smart cities. We have an hospital and agricultural land, and we have a group of schools, and we have some community centers. All of them can be enabled on a single platform through UAV. We can communicate through all of these different institutions, through all of these different platforms via single platform. And UAVs can provide seamless connectivity to all of these, the traffic signal of cities, the flood warning, and the congestion of traffic on the roads, the bicycle lane, and many other scenarios can be deployed and can be mitigated through UAV deployment. So, how can we use UAV in 5G, existing 5G network and beyond 5G network, for instance, 6G and so on, 7G and so on? We can, in future, we can enable our network based on UAVs. Although we rely on backhauling, we rely on bandwidth for the past network, but most of the sites rely on flying base station, and the master site, we can say it, a parent site is the old traditional base station, which we call terrestrial base station, and the newly launched on your site, the rollout site can be UAVs, which can definitely lower the cost of deployment of 6G and also the timing for 6G. And also we can extend our existing 5G network through it. So it's not necessary to launch it in 6G. We can extend, or we can enlarge the footprint of our coverage area through these UAVs in existing 5G network. So there are some challenges in UAV communication as well. The foremost limitation is its battery life. To remain in air, UAVs need battery time. Higher the battery time, we can deploy it to a maximum time. But battery is the foremost limitation, and we are working on it. Also, we have some regulation and privacy concerns. There are some bodies, there are some authorities who restrain to deploy UAV without their permission, and we have to take prior permission before them. There are some, security concerns raised by some law enforcement agencies. So there are some limitations of UAVs. And also for deployment, we need to identify the best appropriate precise position for maximum coverage, its trajectory, what are the candidate points for UAVs to be launched, means to, to minimize the battery consumption for higher time in air. We have to decide it priorly, what are the path of UAVs which it can be traveled to supply the seamless coverage. Or we can say, before the launching, we can launch it as a pilot project for the checking the its original battery time. So emerging technologies, AI and machine learning is emerging, in this aspect of life. In all spheres are changed drastically, and communication is also no exception. So AI and machine learning are infiltrating in wireless communication, and deep reinforcement learning. This is the game changer for UAVs deployment, because it has a model of agent, and agent can reply with a with respect to time through its client, and it can deliver measurement reports to UAVs with respect to with some time duration. So it can be a game changer for UAV. And future UAVs, we can say innovation for advancement and ongoing research should be focused on real life example. Massive MIMO. We can deploy massive MIMO through UAVs for capacity enhancement of our network. And lastly, potentially replace own infrastructure, as current infrastructure is hefty iron tower, which cost millions of dollars. So the cost effectiveness, it's the main aspect for launching UAV, one of the main aspect of UAVs in launching. So thank you. That's all from my side.
Fantastic explanation. Thank you, Ida. I really appreciate that. Now, let me introduce our next speaker, Stephanie Cashel from Waikato, New Zealand, to present on cybersecurity in space.
Yes. Does it work?
Yes, it works.
Nice. Okay. So hello, everybody. My name is Stephanie Keiche, and I studied physics and geophysics, and afterwards moved into the domain of cybersecurity. So thanks for joining us all today, and let me start us off with the Viasat hack, and that was in 2022. And this is, I want to open with that because it was basically the biggest hack when it comes to affected satellite systems. So basically one day before Vladimir Putin launched his invasion of Ukraine, we saw this hack of satellite internet, the biggest one we've ever recorded. So basically the Ukrainian military communication system started to fail, and it wasn't just them. Across Europe, critical infrastructure like wind turbine monitoring systems were affected as well. So this goes directly to show what global consequences an attack on satellite communications networks can have. And just for explanation, if you are curious about how they did it, the satellite was owned by Viasat, which is a US company, and the attacker got in through a vulnerability in their virtual private network. And starting from there, they managed to deploy malware and hit 45,000 modems, which were then wiped. And with that, basically cutting off their connection to the satellite and to the internet. So obviously, we rely very much on satellite technology. And here are some examples. So communication, emergency services, disaster prediction and resilience, but also GPS. And the US, China, Russia, and Europe, they all have their own GPS systems to stay independent. We see weather forecasting, but also financial services. Like, for example, your ATM machine relies on time to keep everything synchronized. And that time is usually provided by a GPS receiver. I could go down the list: maritime, agriculture, everything relies in some way on satellite technology. And if someone would take that away, think about what would that do to you? So let's talk about threats and risks. And I very much like the sentence, if it can be done, eventually someone is trying to do it. And so here are some examples at the very top. So this is basically the main thing my talk is about. talking about the threats and vulnerabilities that exist when hacking satellites or ground stations. At the very top, there is the supply chain attack, which is very popular. Let's take, for example, Airbus, a company that you might all know. And Airbus has over 20,000 small suppliers, and some of whom contribute to software. So there's a lot of attack surface, it makes for an attacker much more sense to hack into these smaller suppliers who don't have that level of defense that, for example, Airbus has. So it's much easier to hack into one of those. The next one is direct network attack. So we see things popping up like ground station as a service. Microsoft and AWS already provide those. So hacking satellites has now become an issue of hacking the cloud. The next one is software vulnerabilities. There's a problem with patching a satellite just because some satellites were launched 40 years ago and have not been patched since then. And also patching is in general a problem because it requires memory on the satellite. And memory is always hard to come by because in space we are struggling with some limitations, like when it comes to weight and these kinds of things. Spoofing hardware, denial of service, ransomware, for example, is an attack where you would play a man in the middle. It's called where you can basically intersect or help the data for ransom as soon as you're basically getting into the uplink and downlink. So that's possible. And if you help the data for ransom, and then you can basically render the whole satellite invaluable. Then there is the physical attacks, for example, jamming. So you could take your let's say truck next to a ground station and use a jammer to basically jam the uplink and downlink signals. This is not an attack that would be held up for long, but it definitely has impact. Then there are more simpler versions of physical attack, but nonetheless very impactful, like, for example, fire of a ground station, or talking about space debris, which is also a big problem nowadays. Space is getting more and more crowded. We see a lot of pico satellites, for example, it's called. And these smaller satellites, they do not always have the capabilities of moving out of the way from a space debris. And therefore, they would then collide and cause even much bigger debris. So it has a little bit of a cascading effect to it, and it's called the Kessler syndrome. And the last one, weak or no encryption, we see that with a lot of satellites from the older generation, but also because of the constraints, also many new satellites do not use encryption. So, yeah. So basically the main consensus is that we need more cybersecurity in space. But since it has not been practiced that much over the decades, there is not a lot of expertise yet when it comes to securing satellites. And while it would be ideal to equip satellites with every possible cybersecurity measure, state-of-the-art software defenses, encrypted communication, and robust hardware protections, the constraints of space, starting from limited power to strict weight and budget considerations, often force us to make these difficult trade-offs. Okay, so like I already I said, there are some constraints when we are looking into space, starting from size and mass. In space, size matters and mass matters even more. So if your satellite extends the scale beyond the launch provider's limit, it simply won't launch. So every gram needs to be accounted for, and the cost of just launching 1 kilogram more can range from thousands to tens of thousands of dollars. Next one, very critical, is power. Very critical, most satellites rely on solar panels and batteries, and managing the power is very challenging, also because of the thermal constraints. The satellite spends half of its 90 minutes orbit in sunlight and soaking up the heat, and other half in darkness. I won't go into every constraint that there is, but basically let me round it up by saying the historic focus has traditionally been on functionality and reliability and not so much on security. And these older systems were designed in an era when the barrier to hacking satellites was extraordinarily high. But the situation has changed dramatically. The democratization of space technology, coupled with more and more cyber attack capabilities, has lowered the barriers immensely. And basically, just this is the last slide showing you the exponential growth of the number of active satellites in space. And there, that does not even talk about the 120 million pieces of debris that are stem from launches, collisions, and so on. So it's basically the number of satellites that you see here is equal to an increasing attack vector. And yeah, I hope I was able to draw some attention to the rising problem of space security. Thank you.
Thank you, Stephanie. Great talk. Appreciate that. I think the 5G NTN is something that we are looking forward. There's a lot of developments undergoing, particularly on the space security as well. And there will be more discussion to be finalized during the World Radio Communication 27, WRC 27 in year 2027. We can see a lot of developments in this area. Perhaps we can discuss during the Q&A at the end. Thank you. Yeah. And let me introduce our next speaker. I would like Christine Fraser from the Randstad, Netherlands, to present on why is robotics moving super fast and super slowly at the same time. Over to you, Christine.
Hi, everyone, and thanks for the introduction. Yeah, today I wanted to talk and touch on robotics. I know that there's some speakers later also touching on robotics, but for me, I wanted to kind of do a higher level presentation for this particular group and talk a little bit about why is it that there's a lot of buzz about robotics, but it seems to be something and an industry that there's a lot of promise, but it's also moving quite slowly at the same time. And to introduce myself, I'm Christine. I'm the founder and CEO at Asomovo. Asomovo is a robo DevOps development solution. And I also sit on the IEEE Robotics and Automation Society's Industry Activities Board, and we're members of the Open Source Robotics Association. So yes, robotics, and people have been talking about the rise of robotics for a very long time, for decades and decades. Here's just 3 front pages. And there's always a kind of element and a feeling people try and put into robots. And in all of these, they are showcased as humanoids. And there's humanoids as just one aspect of robotics. And robotics has got this huge kind of potential to really revolutionize the way we live, work, and play. But very few of us are actually seeing it part of our everyday lives. So kind of what's going on. So there's about if we kind of look at the robotics market historically, you look at the overall robotics, and over about 60% of those are what we call kind of pick and place machines, or a robot arm doing something quite fast, which you just put a cage around in a factory. And robotics has been that for quite a long time, and that's really revolutionized a whole load of industries by making whole operations significantly faster and much more efficient. But as soon as you take those cages away and you start having robots that move around, there's a huge amount more uncertainty and safety issues come in. And so we have this kind of big kind of battle going on globally at the moment about autonomous mobile robotics. And obviously the mega use case is driving. But if you take the cars out of it, there's still only about 3 million robots running around globally. But that is projected to go very fast. And so as soon as you start taking robots and giving them more autonomous behaviors, that's where stuff gets quite complicated. And the robotics development process at the moment, if you speak to robotics developers, it's very slow and frustrating. The tools aren't really, the professional tools aren't really there. The whole process is quite laborious, and everyone's kind of saying, is AI a magic answer? And as soon as you start doing complex behaviors, you obviously start having large data files as well. So things like 5G and how you get autonomous behaviors and data and everything moving around easily between hardware and say cloud applications becomes very, very topical. So if you kind of go and speak to lots and lots and lots of different robotics companies at the moment, there are things that are their most pressing issues. And those most pressing issues can be around that the tooling and the professional tools that they work with are still a bit clunky. People still work extremely much in silos, and a lot of robotics development, because of the way the tools are, is done in quite siloed. But as soon as you want to do something complex, you hit barriers around compute or skill sets, and that then limits the performance of what you have. And there's a big lack of standardization globally when it comes to autonomous behaviors. And there's still a kind of 1 foot in academia and 1 foot in industry when it comes to autonomous behavior building and who kind of unlocks that. So if you turn that more into technical problems and what are the things that we're trying to do, when it comes to robots actually moving around, there's limitations around sensors and actuators, and that's been for decades already. And so that slowly unlocks. And if you look at the biggest problems people had in robotics 10 years ago, 20 years, 30 years ago, most of them are mechanical. But as robotics begin to move around how they communicate, and that can be with each other or back to home base or with things that they interact with, this is becoming more and more. And obviously large language models and AI can unlock some of this, but there's a lot more to communicate than just large language models. There's the actual complexity of situations that they're being used in. And as soon as you take robotics into more public places, those are full of uncertainty. You could argue that driving a car down a road that's already got lots of rules is a kind of known situation. And the fact that Europe's got 25 different countries, all with lots of 25 different rules, makes Europe much more complicated than, for example, America or some larger countries where the driving system is more consistent. And then as soon as you get into doing, again, more autonomous stuff, you've got compute power and then moving those kind of data files around. And then obviously security and things like that. So if we look purely at the overall robotics market and where it's due to go, the kind of industrial robotics, that's quite known how that's going to grow, and there's not a huge amount of variation in the numbers about how large that part of the industry is going to be by the end of the decade. But there's a huge variation when it comes to these mobile robotics and how can they collaborate or standardize in order to move for that whole industry to move faster. So around those kind of service robotics, why is there such variation, and why is the potential to move super fast or super slow? And it's because a lot of those companies are still very small, and you need a lot of skills to build autonomous behaviors, and many of them are still also focused on being hardware companies. So then you either have to bring in lots and lots of money to become a bigger company, or you have to find a way to collaborate. And so at the moment, when it comes to robotics applications, which are, for example, tier 2 or tier 3 applications where the ROI is a bit less attractive, so healthcare applications or agriculture applications, which have got potentially the biggest impact on society, those aren't getting to market in the same way that a self-driving car is, that you can just throw hundreds of millions or billions into the development of. So because of the fragmentation of the schools and the tools in the marketplace, and many of these aren't getting to market because it's just too expensive. So if there's a better way to collaborate, then maybe there's a better way to actually move forward. And actually creating more modular robotics or robotics that can be a bit more mix and match, and creating a kind of supply chain around them in the same way that the automotive industry has got a supply chain, then that's potentially the kind of future of robotics, where one person or one company can focus on the hardware that can then be used in 100 different use cases, one for robotics and one for agriculture. But for the audience today, it's what role does something like AI play? And obviously with AI comes a lot of data processing and a lot of data collection. And AI can kind of revolutionize both in the development process, but also from the kind of human perspective when it comes to robotics. And we talk a lot about the future of work, or the future of hospitals, or the future of logistics, the future of cities, and many other people have already touched on those topics in their conversations. But for example, a quote like this, for the hospital of the future, I just want AI embodied in robots, redefining all the jobs. Essentially, nobody says that. Nobody goes, I think, my solution is robots, 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 robots. So people work in robotics, but actually how we get robotics to actually make big impacts in society isn't by saying we just want robotics. It's by looking at the problems, looking at the biggest issues that need solved, and then robotics being part of that answer, working together with the people, working together there to enhance the human experience, enhance the work-life experience. And robotics might not even be the full answer, but it's definitely part of the answer. And then it's how best to get that to market. And so by having kind of more of a human-centered design approach to robotics, and really looking at the tasks or the jobs to be done, and then how can they be automated, and then how can robotics help being part of that solution, is a way to really accelerate getting robotics to market. And the technology is now mature enough that if these two worlds and that perspective is done, then everything can move a lot faster. You've obviously got things like the ethical and the safety issues, which will only come up, and cybersecurity. If you've got a fleet of robots in a public space, you want to make sure those are all secure. And how robotics work with humans and how that trust element comes into the equation will also be a big part of the future. So when it comes to robotics, it's also about who is writing those rules and who are the standards. And if you look globally at the moment, there's lots of different countries or continents are moving at completely different speeds when it comes to different robotics applications, and who's writing the rules, and what's still in academia and what's actually in industry. And some industries are moving very fast, such as self-driving cars, and others are moving slightly slower. So this is also a bit of a philosophical topic as well as a technical topic. And if those two worlds can come together, then robotics will move faster. Thank you.
Fantastic, Christine. I think the Tesla Optimus robots are available for consumers in 2026. That's not too far.
It's not far away at all. It's not far away at all. Many people, like the one they see the most is something like the lawnmower going around the cutting the grass, or the Roomba at home with the vacuum cleaners, but there will be many, many more.
Fantastic. Thank you, Christine. Let me introduce our next speaker, Florian Humer from Vienna, Austria, to present on digital twins. Over to you.
Hey, thank you, everybody. Thank you so much for having me here and present the topic of digital twins. Maybe some other topic beneath all the topics related to 5G. But the point is actually that digital twins are within this 5G layer essentially as well, but it's only a part of the whole equation, if you will. So I may present myself as well. I'm the co-founder of PropX. We are a 3D digital twin studio out of Vienna based. There are offices in Milan and Dubai we have as well. And we are creating digital twins, urban city twins of cities. And we come essentially out of the virtual reality box, if you will, and we center our focus now on digital twins as a whole and the automation of it, using partly AI, using partly machine learning as we speak. Surely we want to enhance this. I just give some intro now. I hope this is doing, you can see it properly and the latency is not that much. So what we do is, this is a part of a digital twin in Dubai with raw data sources. We can do procedural city generation, and you can experience the city in VR. So we're talking about real cities and not fictional cities, if you will, out of games or something. There can be simulations of crowd and traffic systems if the customer wants it, and there can be a whole bunch of other applications out of these real city twins. This is just some gaming aspect you see here. I'll come to it later, where you walk around as an avatar in a real world city. Now it's in the city center of Dubai where our avatar walks, and you could, easily see what the whole city is about. The point is, all of this emerges from gaming engines. You may know that there are two gaming engines which kind of have the global market share, which is Unity and Unreal Engine. We can do both for clients. It depends on the use case which they ask us for. So all of this you may know from games as well. You see right now in the video. So what actually is the point now of digital twin cities? Why people will increasingly ask for it? So you may know there is GIS, so georeference systems. There is BIM, building information modeling. There are ISO standards. There are ESG standards, especially in Europe. There has been enacted a directive as of May this year, where you have to pull out certain figures, otherwise your real estate will be depreciated as a bank, as an insurance company, as a real estate developer company. So companies need to ensure that they are ESG compliant. So all these theoretical frameworks, which I'm talking about now, there are standard data formats, for instance, for building information modeling. There is the standard of IFC. There is XML standards. Yet all these standards, if you pull them together, they lack interoperability and functionality. What does this mean? So if you want to comprise all these data in one application, you always endure a loss of intelligence. When transitioning from BIM to GIS, for instance, there is no automatic alignment of the ISO standards. And in 100% of the cases, there is no synchronization yet with the EU building directives and the ESG criteria. ESG, environmental social governance criteria, These are the criteria which every company in Europe will compulsorily have to adhere to in the future. Yet these companies doesn't know yet how to get there. So there is a use case, there is maybe money to make on this, because if there is a regulatory framework which companies have to adhere to and they haven't the standards for it, there is room for companies to maneuver. So what else is there? There is a lack of ML-supported data querying or predictive decision. Essentially, if we're talking about smart city twins, city authorities have no clue where the data is. The data is scattered around authorities, around wherever they are, but they have no clue. There is no alignment of these data within the smart city twins. There are now coming digital twin applications as we speak around there. It's very early moving, but what does a digital twin essentially do? A digital twin essentially does combine all or different technologies in one merged application, if you will. Digital twin software is not a software in itself. At least in our view, it's the right merging of different technologies which already exist. And when you merge them rightly, you get your real-time digital twin with real-time data and real-time simulations, which all this thing is about. So what does it comprise of? A true real-scale digital twin comprises of surely raw data from satellite, from street view, from GIS data. It surely comprises also of data utilizing building information modelings. If you are in this area, you know Revit, you know Archicad, you know Navisworks and Autodesk, the market leader in this space, all this data needs to be merged into a digital twin. And again, this may sound easy, but the point is there is no interoperability between the data formats yet. So there is also ISO standards, there are standards from authorities and laws, and then there are complete data sets based on querying languages, which are also not fully compliant with all the 8 other data sets when you want to merge them into the digital twin. So what we do as PropX and as a co-founder is we are already in the verge of creating a kind of operating system for digital twin systems. We already have prototypes. The point is it's always emerging, fast moving. So the point will be for cities in the future. And if you think of urbanization as a whole, United Nations has its estimated 68% of the global population will live in cities by 2050. Imagine 68%. So authorities, city authorities need to know what's going on in their cities. And the only way to do this is to create a digital twin of their cities, which merges all the different data streams. So a platform, as we are building it right now, needs to be a multi-user platform based on a gaming engine. Why in a gaming engine? Because the gaming engines are will be capable or are already kind of, not always, but capable of comprising these huge data sets. So the future will be on gaming engine based digital twin cities. Surely now, because of the 5G limited resources, which has already been laid out by my other speakers before, all this is now more kind of partly offline based on on computers which have the resources for and the graphic cards from NVIDIA, etc. Or it's still browser based, right? So the point will be an exchange of full intelligence of objects, and there will be also the case of having a data token for it to securely via blockchain transfer data from one user to another. So you may think we are not the only company in this space, but there are companies who do have different use cases. So you may have a look at Weegis if you are interested in it. There's Black Shark, it's an Austrian company. There is Aka. What you do is they create outer hulls of digital twins, but haven't been there yet to merge the inner with the outer hull of a digital twin. So there is space for PropX. Why is there space? Just giving you a hint. Fraunhofer, one of the most renowned scientific laboratories for this, they just said that there is a space of 500 to 800 digital twin city projects just in Germany alone annually, because every city will be or needs to be going there. So if you want to have some sort of, if you're interested in us as PropX, we work together with the Technical University of Vienna, with other universities which are very renowned in the use case of 3D digital twins. We did already some projects on it. Have a look at our webpage. We did projects with around 120 builders in the real estate space alone. So check out what we did so far. Very interesting as well in the area of 5G, if you have a digital twin sort of doing your simulations with. So very interconnected areas in my space. So thank you so much for having me here. If there are any questions, just reach out to me. There is the email, the slide you see there. There is the phone number, there is my LinkedIn, and there is my WhatsApp me as well. Just give me a call and don't hesitate to have any questions. Thank you so much.
Your partnership with the universities is a great thing. Brilliant stuff, Florian. So thank you so much. I appreciate that. Let me introduce our next speaker, Runa Biorov from London, UK, to present on what's next for smartphones and connected devices. Over to you.
Excellent. Give me 1 second to get this set up. And if we are successful now, the slide is sharing. And if we are not successful and you are seeing my holiday photos, I deeply apologize.
It's working very well.
Excellent. Thank you very much, and for some great talks we've had already. In the next 10 minutes, I want to redirect us a little bit in a different direction and start to look at devices that actually connect to a lot of the infrastructure that we talk about. Because when we look at 5G or we look at 4G, we have a lot of devices that connect around it. And to really understand what we need from this infrastructure tomorrow, we have to understand what direction those devices are moving in currently. For a little bit of context, this slide represents the number of units that were sold into each of these categories. We're looking at new devices coming into the world. Incorrect way to put on a slide from in H1. This is the first 3 quarters of this year, so from January to September. And there's almost 900 million new smartphones coming into the world. For your reflection and thought, there's over 5 billion active smartphones in the world this year. All of those need either 3G, 4G, or 5G, almost all of them now on 4G or 5G to connect around. And we're now seeing the first smartphone starting to move down to the $100 price segment. So it's really starting to reach a mass adoption. We're looking at almost 200 million PCs, 140 million smartwatches, wearable bands, 100 million tablets, and almost 330 million smart personal audio devices. We track all of these categories in Canalys. So we try to measure and do market sizing on all of them and understand who is the larger players, who is doing well in different countries around the world. But all of these devices are now used together. We've had a past where we've spoken about, let's call it ecosystem, is the term that's often been used, but it's more been a portfolio of devices that have sat around each other, but not necessarily been integrated together. What we believe is the next step to come is that we're moving from a place of integration, where maybe we use Bluetooth to connect, to interconnectivity, where these devices can act a lot more seamlessly and can interconnect and not just be based on Bluetooth, but perhaps we can now start using other, we can call it other ways we interact with our devices and how they are really used together. A part of what will be critical for this shift when we look at our devices is what I like to call an interface shift. So we have to rethink how we actually use our consumer devices around us. And if people actually are ready from going away from just typing, so we all have these nice black rectangles with us now that we type on. And we've typed on every single device for the last 20, 30 years. The question now is if some of the current technological innovation, so that's surrounding partly artificial intelligence, some more generative artificial intelligence coming onto devices. We're looking at network infrastructure being able to handle more data and at a higher speed than before. That can start enabling different type of interaction with the device. So we've already now started to see more voice being used. I'm sure most of you who will see this have used your voice assistant on the phone at some point, which is okay. It is not so great. But what if we're in for a revolution here over the next few years, or a state where, for example, Siri or Google Assistant can get a lot smarter in the way we interact with it? We also now see some products interacting more closely together with the phone. So if you have your AirPods in and someone calls you, you can nod or you can shake your head and it will hang up the call or answer it. We will see more prompts with watches, maybe smart rings, and I'm sure this is a space glasses might sit within as well. So we're looking at these devices coming more together around. A big enabler of this will, for example, be 5G RedCap. We can look at eSIM as a key enabler of actually allowing this technology to be used, but this consumer shift will be a part of it. But the other aspect that if you look at anything in the devices space currently, and I'm sure everyone who will watch this have been targeted with many ads about AI on phones or Copilot plus PC. And in honesty, a lot of what we currently see is what I describe as marketing fluff. It is quite top level. We don't really get to the depth of it. When we see the term, for example, AI too much, we get a bit nervous because we don't know what it actually is. And I think that's where there are some stages we're going through on how the devices are used and the innovation that's happening there. We've had voice assistants in the past, still a thing. We're now moving on to co-pilots where the device we can interact more with it. But what we're looking forward to in the future, so when we talk about AI capable or generative AI capable smartphones, it is more about what the current innovation can enable on devices in a few years' time. Because often what happens in infrastructure and what happens on the actual hardware development first will reflect the uses or the actual use case in 3 years' time, 4 years' time. That's definitely been the case with 5G in many cases where, let's say, the immediate use case for a lot of consumers have not been there beyond just comparing some network standards and some speeds. But what we're looking at in a few years' time is the rise of what we call the AI agent. A lot of industry players would like to talk about this as agentic AI or agentic development starting. So not just where you have a voice assistant that you can speak to, but an assistant that can help you navigate around the device, that can take action for you. Maybe that can delete subscriptions, that can order a coffee. You give it a small budget and it can order for you in the morning. So your coffee is ready in the reception when you show up in the office. And with this, we'll have large language models operating mainly on the device for the communication action model that will also mostly sit on your core device, but also we look at large vision models showing up. So for example, if glasses start to find their piece within the ecosystem of devices we use, this might become even more relevant. Of course, there's still many questions to answer around this. When I talk to operators, even smartphone companies, one of the great discussion is what might the pressure be on infrastructure and networks. If everything is run through the cloud, what will it actually mean for the data requirement? And of course, these can be some tremendous challenges for the industry to face ahead, and is where this balance between what is in the cloud, what is actually on edge on the device itself, is among the major questions we will have to address in the next few years. And I particularly think for any operator, any company that builds infrastructure to help consumers in the next years, understanding the requirements that will come from some of the current AI developments and interoperability between consumer devices development is very key. And this also connects back into privacy and security again. What is actually shared, how much of my data goes out into the world, and how much stays on my device itself. So to give you one little reflection point to finish up with, is that when we see consumer trends, even B2B trends happening, things move very slowly. Often the greatest technological innovations with the greatest impact are often quite quiet and give a marginal cost benefit, for example, whereas the ones with the most disruption outwards tends to often face a bit of a hype wave and calm down a bit. But when we see these hype trends showing up, it is changing how we think about devices working together, how they might fit around us. And anytime we see those show up, I think it is super important that we connect it back to what are the implications on the networks and on the hardware that sits there that helps enable it. And with that, I'll round my little section up.
Great stuff. Large vision models and large action models. Something I learned today. Thank you so much, Runa. I really appreciate that. And let me introduce our next speaker, Nedim Hodzik from Stockholm, Sweden, to present on 5G core integration with force-way ground satellite segment solution. Over to you.
Hello. Yeah. Let me share my set of slides. Yeah, can we see it?
No.
Yeah? Can you
Not
hear
yet.
me?
I haven't seen your slide yet.
Ah, not yet. I'm trying to share. Let me see. Oops. I'm tricky. Okay, now. Okay. Now it's coming up. Yep. Yeah.
Fantastic.
Should be now. Yeah. Thank you. Well, yes. What I'm going to do today is to present, the actual starting off of the project for the integration of 5G NTN into the ground satellite segment solution, existing solution already provided in the market, in the satellite market by the company called Force-way, to which I joined recently as consultant. My name is Nedim Hodzik, and I'm actually 5G core architect working in the mobile telco industry for the 30 years. Worked in throughout all mobile technology generation from 1G to 5G, basically. What this company is actually offering today is this. If you look at the worldwide market, the actual products offering by this company are targeting the underserved part of the market, of the global market, which is sort of suburban and the semi-rural operations. And there is, as you can see, some underserved, some the markets which usually have traditionally some low speed connectivity, such ADSL, 2G, 3G. There are still some markets, some areas in the world which require, which have some kind of low speed and kind of little boost, which can be provided by this satellite technology that is bonded together with this terrestrial connectivity. And yeah, you can see here the satellite router that is provided along with some other stuff that make up these solutions end to end through geo satellites. And what we're gonna do with this project, this is a new project starting off, and we are of course targeting again also this, but also the very rural area, which would require and higher speeds, but still are both underserved and unserved, I would say. So, so we are now trying to expand our addressable market, service obtainable market, and we are targeting, let's say, fixed and mobile 5G broadband, TV multicast, edge compute for un and unserved area. Our actual customers are system integrators, usually, or satellite operators, communication service providers, traditional ones, or TV operators who are entering this broadband market for the streaming and this kind of stuff. So there are sort of these different markets, especially for the system integrators, for onboard connectivity, which are targeting for this with these new solutions, which in flight or maritime or market, or which is unserved, could be buses, some buses or trains. So what we are offering today is a high bandwidth, cost-effective user equipment satellite router terminals, and then also a very powerful SD-WAN gateway, which combines satellite terrestrial in today's solutions, combines this connectivity to provide a better user experience for the end user. And finally, with this, as I said, is we will converge and integrate private 5G solution using our 7.3GPP new radio and core network, where we are going to first start with core network integration. So if you look at how today is served the underserved market by Forceway solution, as you can see, the elements of Extend Hub, which contains this SD-WAN gateway and so-called, plus on top of there is a encapsulator and modulator that is used in teleport of the ground stations to push out and send out this DVB signal, and you can see there's one way on the on forward link and downlink to the end user. What happens in the end user is actually who has already some terrestrial connectivity, but at a low speed, is that then it by this Extend Hub, which includes this SD-WAN gateway, it makes it possible to actually bond these connections and provide the boost as connectivity to the end user connected to this satellite router. And then what we're gonna do for this sort of market is to further make possible is that to add a 5G so-called hub, which contains G-Node B, which is 5G base station, together with the 5G core, and converge them and makes it possible for some use cases, existing features, functionalities, and also products of that solution for the coming market. So if we will try to, or we would like to utilize the current powerful capability of the SD-WAN gateway, which bonds together these two signals into user equipment, custom premise equipment. So what we're gonna do here is that we are gonna provide 2 ways 5G new radio, of which could be also used only one way on the uplink part, or the downlink part, which has a little bit higher efficiency DVB still than new radio interface. So we can, let's say, combine or mix it up different kind of technologies here to provide better connectivity to the end users, the underserved market, which already have some terrestrial connectivity, whether it's mobile or fixed line, to the end user. For the unserved market, which this, let's say, 5G NTN solution targets primarily is of the onboard connectivity, as I said, maritime, train, buses in flight, and some parts of a coverage gap. Again, using initially with a geo satellite, provide two-way connectivity with 5G NR. It's a typical R7 3GPP beginning of solution with the satellite, transparent band pi satellite, and everything is on the ground, processing, modulation, etc., power amplification, and all that kind of stuff. So it's traditional GEO, which are actually upgraded recently, lately, let's say, with the high throughput satellite, the technology, which makes it possible to provide quite large bandwidth and a larger speeds to the end users for better user experience. So this is a solution that we are going to actually develop with specific roadmap over time, which I'm going to get later on. And one of the use cases will be for specific markets is to integrate the existing ForceFree Extend hub with this 5G NTN hub containing RAN, 5G RAN, G-Node B, and the 5G core for better user experience, where we actually use better efficiency on downlink for existing DVB interface over the satellite, and uplink using the from the user equipment 5G new radio. So that is one of the possibility for the solutions we are going to build. And what discuss our technology as the last slide is, and also the roadmap, as you can see on the left hand part of the side, is that today, what I already said, what kind of let's say speed we provide to the end user with the current solution, but you can say that ForceFree Extend hub containing this SD-WAN gateway. And on the right hand is a classical TAV dish with LNB connectors and book to coax cable connected to this ForceFree ODNI satellite router, providing the typical broadband internet service to the end user. And tomorrow, as you can see, if you see timeline of our roadmap, so what we have today, this Odin, this is actually our product name for the user equipment or customer premises equipment connectivity, and there is also streaming and content distribution solution provided to the market for the multicast, TV multicast, etc. And then Extend 5G is a two-way satellite system combining mobile 5G NTN and satellite DVB. And then we have also in the plans, in pipeline, developing over the time, the connectivity via LEO satellite installation, which has a new EU, new European Union satellite constellation that will be built to compete on the satellite LEO market with the current players, Starlink, Kuipers, and some others. And our existing technical platform support all of our development, which will be, of course, then upgraded. We are going to build new platform based on 5G NTN, but that in specific use cases also integrate with the existing solution, which serves the current customers with broadband service. So it's with the new solution, as main point is to emphasize is to we are targeting mainly this coverage gap and in onboard connectivity, which is sort of in flight for the aircrafts and buses, trains, and maritime industry for the ships. So we can provide with even slices some enhanced mobile broadband solutions, all provided from geo high or very high throughput satellites, which are already in the orbits, and the company ForceFree with its ground segment satellite is using already and today for the Extend hub solution. providing broadband internet services to the underserved areas. So we are going to expand to unserved areas as well with the 5G NTN. That would be my presentation for today. Thank you for listening. Thanks.
Brilliant stuff. Thank you, Nadine. Appreciate that. Now, let me introduce our next speaker, Marcos L. Romero from Sao Paulo, Brazil, to present on generative AI within 5G and beyond networks.
Hello, Ganesh.
Yes, Marcos.
Let's share my screen. Are you seeing my screen?
Yes, sir.
Okay, so hello everyone. My name is Marcos Romero. I'm a PhD candidate at Federal University of ABC in Brazil. And it's a pleasure to be here at the Global 5G Evolution Forum with so many experts here. First of all, I'd like to say that the previous presentations have been incredibly insightful. I'm truly impressed by the innovation shared so far. It's always great to see how much we are pushing the boundaries of technology. Well, since I'm joining from Brazil, it's currently 11 hours earlier than in Singapore, so I was up at 4 a.m. to be here with you. But seeing the amazing discussions and ideas today makes it worth it. Well, today I'm be talking about how we can make simulations even smarter and more efficient with generative AI and digital twins. And once again, thank you to Kanesh for the invitation. And let's get started. A little bit about me, about my background. I hold a master's degree in information engineering from Federal University and two bachelor's degrees, one in information engineering and another in computer science. And now I'm a PhD candidate also at the Federal University of ABC in São Paulo, Brazil, where I focus on applying AI and generative AI to core network management and optimization. And I also bring 15 years of hands-on experience in the telecommunications industry in Brazil. Throughout my career, I have worked extensively with 5G core networks, automation strategies, more recently in digital twins and AI-driven solutions. And I think this combination of academic research and industry experience has allowed me to explore how emergent technologies can solve our real-world problems and challenges in the telecommunications industry. And here I have a QR code here to my LinkedIn. If you would like to connect, it would be a pleasure to keeping in touch. So a little agenda here to what I'm bringing today. I'm sharing these insights both from my PhD research and from real-world applications we're developing in the industry in Brazil also. Here is what we'll cover. We'll explore how Gen AI is revolutionizing key areas like network optimization, security, configuration management. I'll introduce our project named HyperTwin, developed at Team this year, that takes digital twins to the next level with network digital twins with the automation and real-time validation for the core network elements. And we'll also discuss how combining these technologies can predict challenges, optimize operations, and make networks more resilient and efficient. And I hope this provides a comprehensive view of how cutting-edge research and practical implementations are coming together to shape the future of 5G and beyond. First, to put in context the Gen AI, generative AI or Gen AI, it was a rapidly growing subfield of artificial intelligence. And to understand Gen AI, it's essential to see where it fits within the broader AI landscape. So, as you may already know, artificial intelligence encompasses the systems that simulate human intelligence to perform tasks like decision making and problem solving. Inside this broader area, we have machine learning, ML, that is a subset of artificial intelligence where models learns patterns from data to make predictions. And deep learning, a branch of machine learning, uses deep neural networks for some complex tasks. And then finally, Gen AI goes a step further by creating new contents, whether that's text, images, audio, or data, by learning from existing patterns. And these creative capacities drive innovation across multiple industries, including telecommunications. We already saw some presentations talking about future trends pointing AI in 5G networks. We have other presentations talking about digital twins in smart cities, and others talking about AI agents. So there's a really exciting topic. Some I got this image from Gartner that brings us to the current state of generative AI. So we saw 50% actively accessing this technology, 43% piloting, and 9% in production, only 8% not considering yet. So the industry in a general view is moving to research generative AI, piloting, assessing. So it's a very important field now. So some applications of generative AI. Generative AI has a broad range of application across different industries. Healthcare, we can talk about Gen AI assisting in drug discovery, creating potential molecular compounds, enhancing medical imaging. For diagnosis, we can talk in finance. Gen AI is used for fraud detection, generating synthetic data for training models, improving risk assessments. We have the entertainment. Gen AI enables content creation like AI generated AI generated music, videos, scripts, virtual avatars, game design, and finally in telecommunications. Gen AI also is transforming network optimization, security enhancement, and digital twin simulation, traffic prediction, resource allocation, and security. These applications demonstrate general versatility in solving complex challenges and driving efficiency among these industrial sectors. And deeping a little dive in telecommunications industry, generative AI is making a significant impact. The key applications in this field include security, uh, for instance, with anomaly detection using syntactic data to train systems, and cyber threat prevention, configuration management using LLMs, large language models. GenAI automates network configurations, translating humans' intents into precise technical commands. We have also research education, which GenAI can help optimize bandwidth and computer research, allocate network slices, and finally, digital twins. By simulating network environments and behaviors, GenAI can support the creation of digital twins for testing and optimization purposes. So in security is a critical concern in 5G and beyond core networks and every network. And GenAI can offer the advanced solutions for network security. For instance, detecting anomalies, generating synthetic attack data for training security models. And for example, we can cite GANs, generative adversarial networks, which can produce realistic malicious traffic patterns, enable security systems to recognize and respond to the threats more effectively. And the ability to generate diverse attack scenarios helps improve the accuracy and resilience of intrusion detection systems, making networks more secure against many threats. So this is an important sector. And configure networks is another topic, particularly with large language models, which can interpret natural language requests from users and automate policy generation, ensuring configurations with network requirements. And this automation reduces the risk of human error and speed up the deployment times, helps manage the complexity of 5G and beyond core networks. And the network resource allocation, as we talk, against and predictive models can analyze network demand and generate optimal allocation for different network slices, for instance, enhancing mobile broadband, ultra reliable, low latency scenarios, and massive IoT. And finally, network digital twin are with together GenAI. Network digital twins are virtual replicas of physical network components, allowing operators to simulate and test network changes before implementing them in the real world. So when we combine generative AI and digital twins, we can enhance the simulations by generating realistic scenarios such as cyber attacks, traffic congestion, and network failures. In the concept of network digital twins, bringing it a step further, we explore this concept in the HyperTwin project. Is an innovative project we developed at TIN this year. So HyperTwin builds upon the principles of digital twins, but incorporates additional capabilities for automation, real-time emulation, and continuous validation. We leverage the libraries of exchange protocols between network elements, and we can emulate virtual elements that behave identically to their real-world counterparts and adapt to specific simulation scenarios. And this tool represents for us a forefront of automation and automated testing and changed the way we work, ensuring high quality network process of acceptance tests and validation of network efficiency. So with integrating by integrating generative AI and the HyperTwin, we can create adaptive simulations, predict potential challenges, and optimize operation, And this combination makes our networks more resilient, efficient, and ready for demands of 5G and beyond. So, in conclusion, generative AI is set to revolutionize 5G and beyond network by enhancing security, automation, configuration, optimize research allocation, support and digital twin simulations. And the integration of Gen AI and digital twins provides a powerful framework for managing complex dynamic networks with greater efficiency and resilience. And for future research, we are looking to hybrid approach using LLMs and SLMs and some specialized agents too. And also we always have the security concerns, the security issues that may be addressed in the future research. So thank you again, Ganesh. I leave my contact here and looking forward to your questions and discussions on how we can further advance. Thank you.
Fantastic, Marcos. Thank you so much. I really appreciate that. Let me introduce our last speaker, Charles Henry Marau from Paris, France, to present on metaverse, IA, and music entertainment. Over to you.
Yeah, you. Sorry, I don't arrive for the camera. It's you. Okay. I'm here. Sorry, guys. So, my name is Charlie, and give me just 1 minute for partage my for sharing my files. I don't find again. Sorry. Alors. Okay. So for this time, I think we work. All people are present a lot of technology today, and I prefer to explain a use case for the 5G for the next years. So I'm Charlie, and since 10 years now, I work on VR and music industry in France, in Paris. At time, we have a lot of consideration for the latency, and it's an important thing for the next few years because metaverse are very important in few years because you have a lot of traffic, and virtual reality and headset, it's like a mobile today, and we have we need a lot of 5G or 6G for the next few years. So the first things, it's present to you augmented reality possibilities. For example, we can find maybe you understand the things about virtual reality concert in Central Park with gorillas. I can present you this. So that's the first things I can present you. If I arrive, sorry. Okay. So I'm so sorry about. Okay. I can find this. I don't arrive. I'm sorry about the inconvenience. Okay, I'm good. You see my computer again? So yeah. Now we have a lot. We need a networks offer blazing fast speeds and low latency. It's very crucial for delivering high quality immersive content and increased capacity for higher density of users connected simultaneously, enabling more immersive experience for everyone. and of course enhanced and reliability, because 5G networks are built for stability and reliability crucial of an uninterrupted experience in VR and AR. Sorry. Networks are critical to the metaverse experience. The likes and glitchless highlight nearness capable fact about the metaverse. Its success will ultimately rest on the quality of the network over which its experience will be streamed. Today, virtual reality experiences are only really accessible over high speed fixed networks, limiting them to home or workplace use. Even then, latency issues can cause glitches, nausea, and headaches. Meanwhile, augmented reality, AR, is tied to the performance of mobile networks. While 4G is fine for simple applications like Pokemon Go, for AR to fulfill its potential as a seamless overlay on the world around us, it will need the kind of high capacity, high rendering, and ultra-low latency that we will only really start to see when 5G advanced networks begins to roll out around 2025. And so that's a typical things we need. Planning and planning for the metaverse means starting with while what we know, early irritation of ITER here today, offering pointers to its future direction and highlighting the technological and regulatory barriers that will need to be overcome. So the role of 5G is very crucial because it's a catalyst for immersive practice. And the 5G speed enables seamless streaming of high-resolution VR and AR content, eliminating buffering and delays. Alors, we have when we organize a VR concert, we have two things: an artist with full body tracking. The full body tracking is always inside a cloud XR just for the artist, and we have multiplayer session too. When we host a lot of avatar and user with avatar, you can imagine that like the concert of Jean-Michel Jarre in VR and inside the internet, classical internet. They have two sessions. One session just for the artist and a big session for a cloud just for the spectator and user. But a lot of time during the experimentation, we have a black screen and a lot of leaks. Yeah, a lot of problems. And if you don't have any stable connection for the next futures, it's the end of VR. So basically, for the new possibilities of music industry and event, if we don't work with the cloud, we have problems. So it's a limitation, but it's an important things for territories, government, for help them to have a good cloud in territory. Okay, so like you see, the first things for virtual reality in the next years, it's retails, and in the second plan, it's virtual events. It's exactly what I say. Virtual events and digital entertainment finally. You can imagine in 5 years in metaverse, the possibilities for cinema, for spectacle, for live show, for nightclub to be inside the metaverse. So it's a new parallel economy. And if we don't have any Wi-Fi or 5G for all people around the world, we have some difficulties for the new market. And with the restriction of climate, etc., we engage a new economy for sure, and we need stability 5G. It's the next big things. So it's exactly what I say. Viens-toi conseiller without latency, multiplayer gaming, and finally viens-toi tourism, because when you have an augmented reality concert into Central Park or Singapore, it's good possibilities for people to go to this place for the concert. So voilà. Aujourd'hui, the future 5G, VR, and metaverse in the entertainment industry, it's very important because transformative everything, like XR. XR is VR and AR experience into the metaverse. It's the globality. So if you have the global reach, metaverse and 5G connect people globally, fostering community shared experience. But for sharing good experience, we need a good 5G too. So now you can imagine the use case for the next years. And I'm sorry for my English, not easy all the time, but I think this you can understand the next challenge for our industry and why we need good 5G. Voilà.
Fantastic, Charlie. I appreciate that. Thank you so much. That was brilliant slides. Fantastic. So to the speakers, please switch on your cameras and let's have a quick 10 minutes Q&A to discuss the most vibrating question. Are MNOs ready to invest in the future of 5G advanced connectivity, particularly in 2025 onwards? Maybe I could be able to start first. I just want to mention that as we know that 5G is taking in a very good pace, and there's a huge deployment of 5G non-standalones in comparison of 5G standalones. 5G standalones, as far as I know, the last 7 months ago, there is only 49 mobile network operators have deployed out of the 740 mobile network operators worldwide. I don't have the latest numbers as of today, but 7 months ago, 49 operators have reached. So 5G Advanced is very much relevant to the 5G standalone in order to experience the full capacity of the features. So definitely we need the 5G standalone, but the pace is moving very slow. I believe Team Brazil have already deployed 5G standalone, and definitely you have experienced very great features, Marcos. But overall, how we can, I just wanted to understand more from your perspective. How do you see in 2025? Do you think more mobile network operators wants to wait and see, or do you think that they will definitely deploy the 5G standalone in order to experience the 5G advance? Because definitely 5G advance is so important for metaverse, digital twins, robotics as well. So anyone wants to take this up?
Yes, Ganesh. As you mentioned, Team already deployed the 5G standalone, and we are seeing many applications being useful to this application, to these new possibilities that 5G standalone brings to us. but we are in a phase that we are seeking for more applications that could be monetizing and do the payoff of the investment. And I think we have essentially a big change, a huge change in the core network to bring the 5G standalone. And for TIM, a big advantage from other mobile network operators is to have a already deployed network of voice over LTE. So without voice over LTE, we can't have the 5G standalone, because the core to make voice calls, you need this LTE network with voice capabilities. So this is the main challenge to the other operations that don't have a big coverage of voice over LTE. So I think it's one of the challenges to have a huge adoption of 5G standalone. But I think the investment is high, and we still don't seeing the return of this investment with the applications being present now. So we have this balance between investment and market demand to this new technology of standalone.
Anyone else wants to add?
I can try. So basically, with the 5G uptime, we need it inside the what's the name? We need it inside the set. When you have camera for tracking, etc., it's not about Ethernet connection. It's about 5G, and because we need it for tracking a headset without a cable, we need it for body tracking, sometimes for the show, and it's not about just for people and B2C. In B2B, we have a lot of operation. You're talking about, Marcos, if I remember, about the twins, numeric twins. It's exactly what we need at time in B2B, and it's a big dimension. So everything we have different possibilities with headset at home and headset inside the place for VR, arcade, etc. And the capacity of 5G are very important in this place, because if you have 20 players placed together inside a place and with a lot of headsets or something like this, you need a lot of big connection inside the place. But if you, in my case, if I want to sing with a guy in Singapore and I'm in Paris, you can imagine what we need for playing together without latency, etc. So we need to work again about this dimension of 5G, maybe 6G, because the latency, it's important. The intranet and everything are not so far away for me in France and maybe for Singapore. So it's a lot of things we can work with 5G, IA, and some possibilities, but we need, I think, an economic help about this with territory.
Thank you, Chen. Anyone else?
I can add something, Kanesh, because I have experience working with operators on this. 5G standalone is actually contains both a new radio, which is RAN, and core network. Today, in most of the countries in the world, across the world, around the world, new radio is deployed along with LTE technology. Non-standalone core is deployed, which means essentially 4G core, evolved packet core. 5G is standalone core, is very different technology to deploy, to make it work, and requires really good incentive in terms of application that will be monetized on their technology. The MNOs up to now haven't found such applications to make it attractive to deploy. They all have deployed internally, but not actually put into the service. Most of the operators have standalone, also tested, trialed, and all kinds of things, different things, including recent, for example, in Sweden in summer for the 5G broadcasting network slicing that was used 5G standalone, but that standalone actually is not yet in a live operation. It was just a sort of trial for some sporting events. So the applications that are needed, it is a very different technology because it's based on HTTP, service-based interfaces, on APIs between network functions. Then you need to put in place also 5G roaming, which I work with quite a lot, 5G roaming, where you have also this network application through IP access, and all this has to be put in place. And in Europe it also makes it even more difficult, because if you want to have full 5G standalone, you have to have across the continent, for example, across Europe, across this IPX and the 5G roaming. So it's about applications that needs to be monetized. And I know a real network slicing is only possible by using 5G